Hi grade 12s, this is JP. This is the second lesson on inverse functions. Today we're going to look at restricting the domain of the original function so that the inverse can be a function. And we're going to look at the domain and range of square root functions. Let's start by looking at a couple of very common square root functions. So if my original function, for example, is x squared or any quadratic, any parabola, then what's going to, okay, so x squared, you guys know how the graph of x squared looks like and the graph of minus x squared looks like. If we're now going to investigate its inverse, right? So what will the inverse be of y is equal to x squared? Well, so remember it was y is equal to x squared. If you're going to find the inverse, then x is equal to y squared, and we need to solve for y. So y is equal to plus or minus the root of x. So if I would reflect that graph about the line y is equal to x, so what's going to happen is that it's going to look like that, and it's going to look like that. Okay, but now this is not a function. It's a bit of an issue. Not really, but just it's a first type of equation that you've got, and if you draw it, that it's not a function. So what do we do? Well, we've got y is equal to plus or minus the root of x. So that means there are two equations, right? It means y is equal to the root of x, and that means it's y is equal to the minus the root of x. Okay, and then there's two arms to this parabola. So at the turning point, okay, then of course we've got this part here. Well, let's have them the same colors. So let's have the pink part. The pink part is of course the inverse of this part of the original parabola, right? So those two go together, right? If you think about it, if you're going to reflect about the line y is equal to x, it's going to look something like that. And there's that. Okay, and then the other one, let's say that's the purple part. So there's that arm there of the original function. If you reflect that about the line y is equal to x, okay, so then you're going to get something like that, right? So, and that's that, it's that purple part. Okay. So how do we know about them? Okay, let's look at the domain and range. So this is what I mean by a square root function. It's one or the other. So the pink one on its own is a function. The purple one on its own is a function. In other words, the root of x or the root of minus the root of x is a function. But of course, together the inverse of x squared is not a function. So let's look at the domain and range of each of these. So remember, what's domain? Domain is all the possible x values, right? And what is range? Range is all the possible y values. Okay, so let's go for it. What will the domain be of, this is the pink one, right? Y is equal to the root of x, that is the pink part there. What will be the domain? What's all the possible x values for that graph there, y is equal to the root of x? Well, what is the smallest x value? That the smallest x value is going to be right there at the origin, because the original function's turning point was at the origin, 0, 0. The inverse function's turning point will also be at the origin. So the smallest x value would be 0. So in other words, it will be x is greater or equal to 0. Good. And what will be the y values? So that's the domain of that one. The range is all the possible y values. Is there any limit to the y values? No. Let's look at this. No, there's not. So that will be y is greater or equal to 0. The smallest y value that you're going to get would be at 0, and y will just keep on increasing, as of course x would increase. Okay. Let's look at the domain and range of the purple part of this inverse function. So what we've got there is the purple part. So x values are still greater or equal to 0, right? The smallest x value would be 0, and it will just keep on increasing. The y values is now not going to tend to be greater or equal to 0. The smallest y value is 0, but then it is going to get smaller and smaller and smaller and smaller as x increases. So that would mean that y is less or equal to 0. Okay, so that's the domain and that's the range. Let's look at the domain and range just of the original function. So the domain and range just of f of x, right? What was the domain of your original parabola? This parabola is quite colorful now, but of that parabola, what's the domain here? Well, it's all possible x values, right? From negative infinity to positive infinity, all possible x values. In other words, x is an element of real numbers, we say then, or from minus infinity to positive infinity. Okay, so that's all values of x. What was the range of the original function? It would have been y is greater or equal to 0, right? The smallest y value is 0, and then it just keeps on getting bigger and bigger and bigger. Okay, so check what happens. So if you look at this thing as a whole, of course the positive arm there and the negative arm there. So what would be the domain and range of this as a whole here? So the domain would be all the values greater or equal to 0. Okay, do you see that swaps around? And the range would be, what will the range be? It will be all, any y value, right? This is going to get bigger, bigger, bigger. That's going to get bigger, bigger. Smaller, smaller. So it can be any value of y. So do you see that the domain and range of the original function and the inverse, they of course swap. Why? Because domain is all the possible x values, the range is all the possible y values. What happens if I reflect about the line y is equal to x? In other words, what happens if I find the inverse? Your x and y values swap, right? Okay, so that's the important part. So that was a lot said. Just in a nutshell, what happens? The domain of your original function, right, becomes the range of the inverse function. The range of the original function becomes the domain of the inverse function. Hopefully that makes sense. So that's a very important link that we need to establish. Okay, let's just illustrate it by looking at the negative parabola. Okay, so we've got a turning point here, 0, 0. Okay, if you reflect this about the line y is equal to x, you know your parabola will look something like that. Okay, so 0, 0, there's 0, 0. Okay, and what would happen? So we've got, let's have it pink again. No, what do we do? Purple for this arm here. If that part is purple, what will be its inverse? So the line y is equal to x is running like that. If you reflect about the line y is equal to x, which arm do you think it is going to be? It's going to be this dude, right? It's that arm. So those purple ones go together. And this arm here, that pinky, right? If you reflect about the line y is equal to x, that's going to go somewhere here, right? It's going to be somewhere there. And that's that arm there, right? So there we go. So the pink ones are inverses of each other, and the purple ones are inverses of each other. All right, so what do we have? So what is the equation of this inverse? Remember, now we've got y is equal to minus x squared. So if you do the inverse, x is equal to minus y squared. So minus x is equal to y squared. So that would mean that y is equal to plus or minus the root of minus x. So that simply means that this top part here is y is equal to the root of, that's minus x, is equal to the positive root of minus x, and the bottom part here, the purple part, is y is equal to minus the root of minus x. Some of you might get a bit of a grill here, so because you see there's a negative inside the square root, fear not. If x is negative, right, then a negative times the negative is a positive, then you can still get an answer. You get a real answer. But x can't be positive. Do you see the graph is not on the positive x value? So in other words, if you substitute 1 into x, or 2 into x, or 3 into x, you're going to get non-real values. But if you're going to substitute minus 1 or minus 2, minus 3, you're going to get real values. Okay. If what I just said made little to no sense, just look on page 56 and 58 in your textbook. There's a couple of there's those square root graphs, and then there's a summary of the domain and range. Right, I do think it's very important. Okay, so I would advise you just to quickly look at page 56. There's a column on function, domain, range, and then the graph. And then on page 58, you'll see the its original function and the inverse. I think please do that before you move on. Okay, so I'm going to look at a couple of questions where you'll be given a function and ask you to restrict the original function so that its inverse will be a function. Okay, so let's start with the most basic of parabolas, y is equal to x squared. So I think it's just always good maybe just to make a rough sketch just about what is happening here. So you've got your x squared, right? And then you're reflecting that about the line y is equal to x. Okay, and let's do the inverse on a separate one. So then what's going to happen is you're going to get two arms. So the first one, let's say this is the pink part, right? That's going to be like there, and let's call it the purple part, this part here, and that is going to be there. All right. So, and what we know then, we just looked at this now. So that means this is y is equal to the root of x, and that means y is equal to the negative root of x minus 1 times the root of x. Okay, how do I restrict the domain of the original function for its inverse to be a function? What the hell does that mean? That means simply I need to just include one of the arms. It's either the purple arm or the pink arm. All right. The purple arm's inverse is a function. The pink one's arm is the inverse of the pink one is a function. All right. Together, it's not a function. All right. Remember, this is like bad relationship stuff. So what do you do? Okay. The only thing you need to worry about is you look at the turning point of your original function. Remember, this is your f of x, and then this is your derivative function. So you're looking at look at the turning point. Okay, where's that mirror image in the graph? That is at the x value of the turning point, right? In this case, it is x is equal to 0. There's a mirror image. Okay, so in other words, if I talk about x is less than 0. You understand? I'm talking about the purple graph here. I'm talking about this part of the graph, only about the purple part. And when I talk about x is greater than that x value of the turning point, in other words, x is greater than 0, I'm only referring to the pink part. Okay, I'm only referring to that. Okay, now let's consider that. If x is less than 0, this part here, okay, that means that is a function. So if I restrict the original function's domain, the x value of the original function, if I say, well, if x is less than 0, well, that would mean y is equal to minus the root of x, and that is a function. It's that purple part that that's drawn there. If I say x is greater than 0, it's the pink part, right? And then you get that part, that's for the inverse. That would mean that the equation y is equal to the root of x, that is a function. So it's not very difficult. You're looking at the turning point. It's all to do with the turning point of the original function. The x value of the turning point, x is equal to b, the x value of the turning point, is that mirror image, right? It divides the two legs of the parabola. And then it is just x is less than that x value and x is greater than that x value. Let's look at a slightly more complicated question. So f of x is equal to x minus 3 all squared plus 1. Okay, rough sketch of that. I think it just helps you. I think it will guide you. Is just the turning point here would be at 3 and 1, right? So 3 and 1. So your parabola currently looks like that. So just a rough sketch. Okay. So then we're going to reflect this about the line y is equal to x. Okay. So that means this parabola, it's got two parts, no? So it's the pink arm of the parabola and there's the purple arm of the parabola. Right, very good, the coloring in. So we're going to restrict the domain. We're going to restrict the x value of the original function, okay, for its inverse to be a function. How would the inverse look like of f of x here? So if this is y is equal to f of x, how would the inverse look like? So first of all, our turning point in the original function was what? What did we say? 3 and 1. So now our turning point is going to be at 1, 3. Okay, so that's important. And then what's going to happen is this y-intercept here is going to become an x-intercept, all right? So in other words, what we're going to get is we're going to get a parabola that looks something like that, all right? So it fell on its side, but just be very careful of that turning point, right? So then we've got the two arms. So the purpley part, this part here, right? The purpley part is going to be what? If you reflect this part about that line, how would that look like? Right? So this point will be there, that point will still there, and it's going to go other way around. So it's going to look something like that, right? And there we go. There it is. So here we go. So there's that part. Okay? And the pink part is going to be the top one. Alright, so let's do the equation as well now. So if the original equation was x minus 3 all square plus 1, and if I'm finding the inverse, so that is when x is equal to y, then that's going to become x is equal to y minus 3 all square plus 1. So you're going to minus 1 on both sides. It's minus 3 all square. And then you square root on both sides, so plus or minus x minus 1 is equal to y minus 3. So therefore, y is equal to 3 plus or minus the root of x minus 1. Okay, so that would mean this is 3 plus the root of x minus 1, and the y is equal to that, right? And this one is y is equal to 3 minus the root of x minus 1. Good. So what now? So let's now restrict the domain of the original function, so its inverse is a function. So we're going to look at this purpley part. We're going to separate this parabola here into the two arms, the purple arm and the pink arm. So the purple arm there is what? So that will be x is less than 3, yeah. And the pink part is x is greater than 3. So if you restrict the domain there, x is greater than 3 and x is less than 3, then your inverse will be a function. So in other words, what we're actually doing is we're just saying, okay, there's my original, only that arm exists, all right? Therefore, that's going to be my inverse, and that is a function on its own. Okay, hopefully that makes sense. So you're just, in other words, separating those two arms of the original parabola. Let's just quickly look at the domain and the range of f of x. So the domain of f of x will be x is an element of real numbers, right? So that x can be any value. And then the range, the smallest y value you're going to get is at the turning point here, it's the local minimum, so at 1. So therefore, it's all the values greater or equal to 1. So let's look at the domain and range of the inverse function as a whole, right? So without restricting it. So the domain of the inverse function here would be, what would that be? So the domain, we've got x is x, the smallest value of x would be right here. So that would be at 1. So x is greater or equal to 1. And then what will the range be? The range is going to be all y values, right? Y is just going to get positive as x increases, and negative as x increases. So that would mean that y is an element of real numbers. And just quickly, just note this. X is element of real number, the domain of the original function, x is element of real numbers. The range of the inverse function is y is element of real numbers. Okay? The domain of the original function, x is greater or equal to 1. The range of the original function is y is greater or equal to 1. The domain of the inverse function is x is greater or equal to 1. So yeah, link it up. So that's an important part. Hopefully that makes sense. I'm just going to do one example with you, and it's example 11 on page 50 in your textbooks. And I think it's quite important that you do this. I also think it's important just to go through example 10. It's on page 49. I'm going to example 11 I'm doing is on page 50. Just go through example 10 on your own as well. Just read through the question and the solutions. I don't think that's particularly difficult, but let us know if you're battling there. Okay, so let's have a look at what's going on here. So they say there's a sketch, and it shows the graph of a log graph. Boo, a log graph. So, and it is the log graph of f, of course. So let's do a color thing. Let's be colorful. So there's f, right? Maybe let's make this bigger. Hopefully you can see that. And then we've got and the inverse is, sorry, there's the f of x is that, so that is the original function. Okay. Oh, a log graph is now the original function. So what will the inverse be of a log graph? Well, that of course will be an exponential function. So this is the blue baby. So there's the inverse of it. Remember, we've just done up to now. We've done f of x was an exponential function. Then you find the inverse, which is a log graph. Okay, so there that's why it's equal to the inverse. Well, there it says. No. And okay, so that means that's reflected about the line y is equal to x. Okay, and then there's another graph. Whee, there's another graph there. G, the reflection of the inverse of f about the x-axis. I mean, that's not really difficult, eh? So that's just the blue graph reflected about the x-axis. So it's like those questions we've done earlier, but it's just all together now. Okay, the first part is there, determine the value of b. Okay, so what is b? B is the base there. Okay, how would we do that? So our function is y, if f of x is y, it's equal to log bx. B is the base. Okay, so what do we know about this graph? Well, we know that there's a point that the graph goes through, so we know the x value and the y value. Remember, that's a function, so for every x value there's a y value. So if I nick the y into y and x into x, let's see what happens. So, you know, we can only hold thumbs, eh? So then, just joking. So log b and then x is then equal to 8. Okay. Ooh, 3 over 2 is equal to log bx, b8. How does that help us? How does that help us? Just calm down. Remember, this is in log form. If I write this in exponential form, the base, b to the power of 3 over 2 is equal to the number 8. B to the power of 3 over 2 is equal to 8, you say. What the hell does that mean? So, okay, so you can do that on your calculator if you want to. You can just go, well, how to remember in grade 11, we did something like this. You write 8 as 2 to the 3, and you multiply the exponent by its reciprocal, right? So you can do that, and then the answer is equal to those 3's divide, so the answer b is equal to 2 to the 2, and what is 2 to the 2? That is equal to 4, okay? Another way to do it is, divide by 2 is square rooting, so this part here is the same as saying the square root of b cubed is equal to 8. So you square first on both sides, so b cubed is equal to 64, and then you cube root to get only b, and the cube root of 64 is equal to 4. Okay? Okay, so now we know that b is equal to 4. That means f of x is equal to log 4x. Okay, next question. Determine the equation of the inverse of f. Ooh, the inverse of a log graph would be exponential function. So let's see what's happening here. So the log graph is log 4x. If you're going to find the inverse of this, it's probably best to write it in exponential form. So 4 to the y is equal to x, right? Those two things, equations are exactly the same thing, right? That's the equation of that graph. So now we're going to find the inverse. What is the inverse? That is when x is reflected, the function is reflected by the line y is equal to x. And what happens then? So that would mean then that 4 to the y is equal to, oh my goodness gracious me, 4 to the x is equal to y. So there we go. So that would mean the inverse of that function is 4 to the power of x. Okay, so that would be 4 to the power of x. Now we're going to determine the equation of g. So we know that the inverse function is 4 to the power of x. So what happens? The equation of g is that blue graph just reflects about the x-axis. What happens if it reflects about the x-axis again? Those x values stay the same. The y value is multiplied by -1. So you get these x, y, and that becomes then x minus y. So what we're going to do, so the blue graph there, the inverse is y is equal to 4 to the power of x. If I reflect this about the y-axis, you get minus y is equal to 4 to the power of x. Divide by -1 on both sides, and minus 4, y is equal to minus 4 to the power of x. Let's do the next question as well. So the domain of f, what will be the domain of f? Domain is it's the domain of the purple graph. So we said that the original graph is got the x is y is equal to the inverse graph is y is equal to 4 to the power of x. This graph here. And its asymptote then is at +0, right? So it's the x-axis. It is y is equal to 0. What happens again if you find the inverse? Well, the asymptotes, they also change, right? So this y is equal to 0 is then going to become x is equal to 0. So x is equal to 0 is the asymptote. That means this purple graph won't touch the x-axis, the y-axis, won't touch the y-axis, can't touch this, and no, you can't, and yeah, so that's important. So it won't exceed that. So what is the smallest x value you're going to get on this purple graph? You're not going to get any negatives. Is this purple graph ever going to touch the y-axis? No ways. And look at the asymptote on that thing. And then this one is just going to, as x increases, y would increase. Okay, so let's do that quickly. What is the domain of the graph of f, the original function? That would be x is greater than the asymptote, right? So, and what is the asymptote? X is greater than 0. Can it be 0? No, because that's the y-axis. And just quickly think about this quickly. If you've got y is equal to base 4x, 4 to the power of what is going to be 0? Not even if you smoke your socks will you find something like that. So, yeah. Next up, determine the range of the inverse of f and then the range of g. So let's start with the range of the inverse. What's the range of this baby? Well, that is going to be all the y values slightly bigger than the x-axis, right? That would be, of course, the same as the domain of the original function. So yeah, so that is it is y is going to be greater than 0. And what is the range of g? That would be y is less than 0, because that's a reflection about the x-axis. And next up, we need to write down coordinates of a, b, and c. So let's look at a. What is a? It's the x-intercept. The x-intercept of that log graph is going to be the y-intercept of the original function. A and b must be the same, right? Those are inverses of each other. And what would be the y-intercept of the original function? Remember, this was y is equal to 4 to the power of x. So 4 to the 0 is 1. Okay, so what is b's coordinate going to be? B is going to be 0, 1. What is a's coordinate therefore going to be? That's going to be 1, 0, right? Those x and y swaps, right? And what is c's coordinate going to be? That is the point B reflected by the x-axis. So c is going to be 0, minus 1. Okay, so we're almost done with this one. For which values of x, remember we did a lot of those in calculus, would f of x be less than 0? Okay, let's look at that one. F of x less than 0. That means where's the y values of this purple graph below the x-axis, right? So where is it? Where's y here on the purple graph? Negative. It's all the values less than that x-intercept, right? And what is that x-intercept there again? We just worked it out. It's 1. So therefore, it is x is less than 1. All those real values, right? Next one. Which values of x is g of x greater or equal to minus 1? G of x greater or equal to minus 1. Okay, so if we look at the line y is equal to minus 1, So let's check. So where is g of x above the line? For which x values will the y values of g of x be above the line of -1? So what would that be? It's of course, so what happens there? All those x values there g of x will be greater than the line -1, okay? And then at -1, of course, that would be 0, okay? The x0 -1, né? And then greater than -1, the pink graph is below that orange line. So yeah, so that's it. So what is that equal to? So that would be at x is less than 0. Okay. The next part, for which values of x would the inverse of f of x be less than 8? Okay, so less than 8. So the inverse be less than 8. Okay, let's just look at the last part. Sorry, I just realized, just that first part here, for which which f of x is less than 0. It's less than 1, but of course the graph won't get any smaller than 0. So it's between 0 and 1. Okay, so sorry about that. Okay, question 3. For which values of x will the inverse be less than 8? Okay, so this point here, so if you reflect this point 8, 3 over 2, that will become 3 over 2 and 8, yeah? So what's happening then? For which values of x will that blue graph be below 8? In other words, it's going to be all those x values there, right? All those x values, and what is that? That is at 3 over 2 and smaller, so x is less than 3 over 2. All right, and then last question. It's equal to x plus f of x plus by t passes through the point 11, 3 over 2, write down the value of t. What this question is asking, and it just looks difficult, it's not. X plus by t, right? Or x minus p or x minus t just means this graph is shifted left to right. Remember, like y is equal, if it's like f of x minus 2, that means you're shifting it 2 to the right, and if it's like f of x plus by 3, you're shifting it 3 to the left, right? Good. So we just need to know how do you need to shift the graph of f left to right for it to become 11, 3 over 2. So this stage, it is at 8, 3 over 2. So that's at 8. You want to shift it, it still be the same y value, right? But now the x value should be at 11. So that should be at 11, 3 over 2. How far do we need to shift that? We need to shift it 3 units. So 3 units, we need to shift it to the right, okay? And what would that be then? So that's going to be y is equal to f of x minus 3. Y is equal to f of x minus 3, so therefore t is equal to negative 3. If it's f of x minus 3, it's shifting 3 units to the right. Okay, so hopefully this will help you a bit to do some of those questions on exercise 3. Just see how many of them you can do, and yeah, I'll put up the solutions to those.